Welcome to the Teja Statistics. Today we are learning about the designs of experiments. Design of experiment is essential to draw meaningful and valid conclusions for specified objectives under a statistical study. Design of any experiment involves planning, obtaining relevant information regarding the statistical hypothesis under study, and making statistical analysis of data. Planned and well-designed experiments gives us more accurate and fruitful results. So here in chapter 2 we are discussing about the designs of experiments. So what they are saying that the planned and well-designed experiments gives us more accurate and accurate results. Okay, so this is very important. Next, coming to the definition, the design of experiment may be defined as the logical construction of the experiment in which the degree of uncertainty with which the inference is drawn may be well defined. Okay, this is the definition of designs of experiments. Next we have one more definition, that is treatments. Treatments are various objects of comparison applied on one or more experimental units in a comparative experiments. So example, if 5 fertilizers are applied on various plots in the agricultural land, then the fertilizers are treatments. Okay. So similarly we have to see another definition, that is blocks. If the whole experimental material is divided into relatively homogeneous subgroups or stratas, then these stratas or subgroups are known as blocks. An example, in agricultural experiments we divide the whole experimental material into relatively homogeneous subgroups. These subgroups are called blocks. So simply we can say that the column wise division. Okay. Uh, Here the treatments are row wise divisions. Okay. Next definition, precision. The reciprocal of the variance of the sample mean is known as the amount of information of a design or the precision. If an experiment is repeated r times, then the precision of the experiment is given by precision is equals to 1 divided by variance of x bar. Okay, so that is equals to 1 divided by sigma e square divided by r. That implies r divided by sigma e square. So this is very important definition, precision of design. Next, the importance of designs of experiment. A proper design of an experimental or an experiment leads to accurate results. This helps in achieving the objectives of the experiment. Design of experiments is more useful in reducing the effect of errors due to the various sources. The design of experiment increases the precision of the experiment. So more accurate values it is going to give you. Next, the principle of principles of design of experiment support in increasing the efficiency of the experiment. Next, the principle of design of experiments are useful in eliminating the personal bias of any form. Okay, next the applications also they are asking regularly. Next we have to see the applications, that is Applications of designs of experiments. The designs of experiments is extensively used in agriculture and greenhouse studies, etc. The design of experiments is applied to study laboratory techniques, medical experiments, pharmaceutical uh, experiments, etc. Designs of experiments is used in the field of economic and industry. So these are all the some applications of designs of experiments. So importance and applications, and some more definitions we have to see. Next, you have to look at the another definitions, that is principles of an experimental design. So here these are according to R.A. Fisher, the basic principles of an experimental designs are these three. First one, replication. Second one, randomization. Third one, local control. So what do you mean by the replication? A replication means the repetition of treatments more than once under investigation. That is the repetition, okay, executing more number of times, okay. So executing the experiment more than once. So this is called replication. Next, the advantages and disadvantages also they given here. So just look at the advantages of replication. Replication is useful to reduce the experimental error. The large number of uh, replication reduce the standard error. It results in a increasing precision. So by applying the replication, we can avoid the experimental errors, and also we can remove standard error values, and it gives more accurate values in the result. So that's why this is a very important definition, that is replication. The next definition, that is randomization. According to the randomization also we have one more definition, that is the main objective of the randomization is validity of the statistical test of significance. All the statistical tests like TF, normal, etc. are based on the fundamental assumption that the observations are drawn randomly and independent. So randomizations means the observations are fundamentally we are drawing by assuming that it is a randomization. Okay. Next, look at the advantages also. Randomization eliminates any kind of human bias. It provides logical bias or logical basis for conducting various statistical tests of significance. It ensures the experiment free from any systematic effects of environment. And disadvantages also. Randomization is difficult to apply for large number of experimental units. The randomization process can be effectively applied by statisticians only. Yeah, these are the drawbacks for randomization. Last but not least, definition, that is local control. So what do you mean by this local control? Let's see the definition. The process of reducing the experimental error by dividing the relatively homogeneous experimental material into homogeneous blocks or subgroups is known as the local control. Okay, so you can see the local control observations and their uses over here. Next, yeah, the advantages you have to see. The local control reduces the experimental error. Local control ensure the experimental design is more effective by reducing the experimental error to a great extent. We can detect even small differences between the treatments also. And we have the disadvantages also. Uh, if the experimental material is homogeneous, then dividing into blocks is not necessary. So that is application of local control principle is not much useful. And similarly, in general, soil fertility does not follow any systematic patterns. So hence dividing into homogeneous blocks, it is difficult task. So these are all some examples and advantages and disadvantages. These are the three definitions you have to remember, that is randomization, replication, local control in designs of experiment. Very very important. So for final years, paper 6. Okay, statistics. Okay, thank you.